Welcome to Safety is Everywhere YouTube channel. Dear friends, don't forget to subscribe this channel and share the link with your safety professional friends.
Hello everybody, welcome to this lecture. Last lecture you have seen accident investigation and also what kind of analysis is required. We also shown you that what are the different information that should be collected. And in today's lecture what I will do, just I will describe the descriptive analytics part, assuming that you have some kind of data available with you, and those data are basically come from the accident or incident investigation reports or records. Okay. So, in this lecture we will see descriptive analytics, or otherwise you can say descriptive analysis also. But today's world is analytics driven. Whenever you have data, you must try to do analytics so that you will get the best benefit out of it. Okay. So, what are the things we will see today? We will see first the descriptive statistics, and then one example, and finally all those descriptive statistics we will try to relate to the data and give some of the insights to you, and which will ultimately help you in describing the accidents or incident or safety status of a plant for which you are doing this analysis. So, when we talk about statistics, basically statistics means when you have data, you have collected a lot of data is there. So, these data are usually we say that sample data, which is collected from a population or from a process or a system. Then this data can be used to infer or to quantify or to measure some of the basic properties of the population or the process or the system. So, that means what happened, that descriptive statistics include that the summarizing the data, then your charting the data, and then getting location and dispersions measures from the data, and this basically actually describe the what is happening in the system or the process, or from statistics point of view in the population. So, there will be different kinds of measures. One is measures of frequency, then measures of central tendency, measures of dispersion or variation, measures of position. Under measure of frequency, you measure count, percent, frequency. Under central tendency, you measure mean, median and mode, and under measure of dispersion, you measure range, variance and standard deviation, and under measure of position, you basically measure the percentile ranks, quartile ranks and something like this. So, I will not be discussing all those things, but for the for your benefit, some of the things will be discussed today, and rest of the things you please do your self study. So, let us consider a data set. Suppose a company is experiencing serious accident over the last 5 years. They have been collecting records of each of the accidents occurred in the plant. The data consists of 500 records are retrieved from the company for analysis with the aim of to provide descriptive statistics of the data, the attributes used in the described below. So, please remember that means investigations have been made whenever incident has taken place, and let in this fashion the report is available. Report can contain many other things, but for the time being we have created a hypothetical data set, and that hypothetical data set is like this. So, that means every incident report has attributes like month, day, location, incident event, working condition, machine condition, observation type, incident type, employee shift, gender, working temperature, heart rate, blood pressure, health rating, incident outcome, risk, so many things are there. So you see some of the are basically time stamp, some of them are location stamp, some of them are event related detailing, some of them are basically related to the particular victim, some of them are related to the physical process, physical environment like temperature, and also there are some outcomes related to incident, maybe fatality, property damage, and something like this. So most of the things are categorical in nature. Categorical means they are basically just giving you some kind of identity, like day has 7 days, Sunday, Monday, Tuesday to Saturday. So they will from Sunday and Monday, they gives you the identity of the day only, nothing more, nothing less. Okay. Similarly, location, they will tell you which location, whether it is in the plant, on the road, in the shop floor, or within the shop floor, whether in section 1, section 2, section 3, like this. So that sense they are all categorical in nature. Now temperature is numerical, heart rate is also numerical, blood pressure numerical. So working temperature related to the physical environment, heart rate and blood pressure related to the victim, and health rating also related to the victim, that is also numerical, and incident outcomes basically what happened to the victim, and risk means basically it's basically the that event we have seen the probability of happening that event and times the severity. In some scale it is measured. Okay, this is also categorical in nature. So how many categories are there? In the month 12 categories, day 7 categories, like different categories are there. And for the numerical variables, you will get range values, that from which value to minimum to maximum this value you will get. Okay. Suppose you have collected, that means what happened? These are the attributes you have collected from the accident reports. There are 500 such records. So you have good amount of data set. Now we want to do some kind of descriptive analytics here or descriptive statistics here. So here first you see that month wise, that in different months what is the frequency, the percentage. Now if you see the frequency and percentage, you find out that this percentage wise, this is the 12% is in November, otherwise more or less they are similar. Okay. Now if you go by day, I think the day wise also percentage if you say, so from this data 18.4 it is little more, otherwise others are almost equal. Similarly, when you go by division wise you see that division 3 is having percentage, this much percentage, 37.8 percentage, but otherwise others are almost similar. Now these are basically from month, day, location, this categorical data, where different categories and their frequency and percentage is calculated. You can calculate it in this manner also. So you can use a software and get it. But when we are talking about some kind like working temperature, health rating, then they are numerical variables. So in this case you are able to find out the minimum value, maximum value, their sum, one total 500 sum, then their mean value, the standard deviation value. Okay. So working temperature, if I want to analyze what is happening, working temperature minimum value is 30. So this is 30 and maximum value is 45, and then your mean is 37 point somewhere here, 37.64, standard deviation is 4.63. So that means if you see the data is basically ranging from 30 to 45 with mean value here, and standard deviation here 4.36. So it's one standard, this side 4.36. So 37.43. If you go this side 4.36, this is 33. So this is the range variation over the mean. But if you see health rating, its minimum value is 1. Health rating, if I go, minimum value 1, maximum value 10, and its mean value is almost middle point 5.62, and its variance part is 2.6. So this side 2.6, this side 2.6, this sense you will be right. So the mean will give you the central tendency, and variance or standard deviation will give you the dispersion what is happening, and this is possible. This you will get when you have the data in the numerical scale or numeric scale. When you have data in the categorical scale, you will get the frequency values and some probability values or the percentage occurrences you will get, and accordingly you can take the decisions. For example, what will be the decision here? Decision for the month wise, you may say that why November mean value percentage is more, you want to look into this. Similarly, Sunday the value is more, or division 3 frequency is more. So immediate attention will be why, what happened to division 3, what happened is happening on Sunday, and what has happened in November. That may be the quest for from the safety management point of view. And working temperature, if you see that mean value is 37.64, it may be okay, and health rating point of view, suppose it is basically 5.62, but the rating should be, when it is again in the middle value, but it is not good because it should be at the higher level. So that sense you have to understand. So that means now what happened, that means the people, I can say the health rating is not good, so their health to be improved. Maybe health ultimately lead to safety problems. Okay. So this is what is the logic of doing this kind of descriptive analysis. Now there are many charts that can be used. For example, when you are doing the which kind of employees are more prone to accident, then you can use simple bar chart, and in bar chart you find out that contractor are more than the employees. Now if you see the percentage also, if the contractor workers and company employees, they are having equal in number, then this count is in the contractors are more prone to accident. And it may be because contractors are, there may be many contractors coming from diverse background, then there may not be having proper training for those workers. The contractor workers might be changing time to time, so their familiarity about the working conditions is also not that good. Similarly, if you do bar chart for the shift wise analysis, you see that evening shift the accident is more. So it may be you have to see that why evening shift accident is more. You do further analysis on evening shift and then find out the reasons behind it. But nevertheless, we are basically, I want to show you the use of bar chart here. Okay, so bar chart, what happened, in the x axis there will be the categories, and y axis there will be the frequency or count. So here employee type 2 categories, contractor and employee, this side count, and here in case of that shift there are 3 shift and count. Okay. So you can use pie chart. Pie chart, in last class I have shown you. Pie chart will give you basically that when you capture the totality, it will give you the area of the chart, talks about the percentage of contribution for that particular attribute category. For example, time shift, day, evening and night. Here you have seen that your major contribution is evening shift. So that's why the area here is more, share is more. And that same thing if you want to do in line chart here is similar to that bar chart here, but except putting bar like this, you are what you are doing, you are putting one point here, another point here, another point here, and drawing and joining them. So that is line chart, giving you the similar analogy or similar interpretation of the accident or incident occurrences for the hypothetical plant studied. Then there is scatter plot. Scatter plot, when you do, scatter plot is nothing but basically you consider 2 variables at a time or 2 attributes. In this side you are saying that number of incident or incident count, and this side that shift. So and here what a time shift, and then here contractor and employee, 2 kinds of workers are considered. So then the contractor contractor and contractor, everywhere they are more, it is more. Okay. So, although we have basically shown you that time versus the type of employee with the number of incident, but scatter plot, when usually the general meaning of scatter plot is there will be two variable, this side x and this side y. Now, what is the relation between x and y? Okay. So, that means what will happen if we do suppose here that your shift is your day shift, evening shift and night shift, and this side your regular and contractor. Then if you put the values, so day shift and regular, so and this kind of some kind of plot you will get, but better will be when we have suppose this side let it be temperature and this side let it be your health rating for the worker. So, if temperature increasing, health rating decreasing or something like this, it may so happen you will find out something like this curve. This kind of things are described in scatter plot. Scatter plot means it is a bivariate one, two variable case, and this is a special type of scatter plot. What we have done, we have considered two employee type as well as time, and also we have considered the counts. Okay. So, if I consider number of counts versus time shift only, then what happens? Shift means basically that shift 1 and shift 2 and shift 3. In fact, time in between means middle of the shift here, middle of the shift here, middle of the shift here, middle of the shift here. So, that is 18 here, but usually we will not do in this fashion. We will write here suppose shift A or shift A, shift B or shift C. This middle shift, if you want to write shift then ABC, otherwise you write time 24 hours of time from 0 to 8, 8 to 16, 16 to 24 this side, and then contractor and regular employee like this. Okay. So, these are the different ways of plotting the data, but it is clear from this data that regular employee they are having less number of accident or incident compared to contractor employee. And if you compare shift wise, then definitely evening shift is having more number of accident compared to other two shifts. And then that kind of things you can plot a radar chart. What happened here, that contractor employee type, and then night shift, evening shift, day shift, some radar is formed, and just to show you that what is happening in terms of contractor and employee with reference to the three different shifts. This is another kind of plot. So, when if you have your suppose health rating or some kind of continuous variable, and you want to see with reference to categorical variable, suppose here shift day shift, sorry, here day shift, evening shift and night shift. So, then you know that how many incident has taken place in day shift, evening shift and night shift also. Now, you know the victims and their health rating also you know. So, you want to see that what is the variability and central tendency for people in health rating for people who are injured or who are victim in day shift, in the evening shift and this shift. So, then this kind of box plot will give you a beautiful comparison. What is box plot? Box plot basically talks about median value, the middle one is the median value, then this is your first quartile, quartile 1, and this is your third quartile, quartile 3. So, median is quartile 2, this is quartile 2, so quartile 3 and quartile 1, and then this is the whiskers. So, this ultimately this lower than quartile 1 and more than quartile 3. Some whiskers means what is the spread possible from here to here, for this here to here, and for this here to here. So, if you see the mean value in terms of health rating, then in day shift this median value is lower or almost they are similar. But if you see the spread, then day shift worker spread is much more compared to the evening shift people. It may be so that the people who are victim in the evening shift, their health rating is spread is less. So, okay, now doctor, if you ask doctor, then they can tell you why this pattern of health rating is observed. Okay. So, doctor will help you. So, another way of representing this is through histogram. Histogram, when you talk about histogram talk about only one particular variable which is basically numeric in scale. Okay. So, that means here health rating. So, what it does basically histogram from the minimum to maximum with certain range, small range, number of counts, number of frequencies or frequency is counted. For example, I can say that health rating it is 1 to 10. So, then up to 10, suppose you 1 to 2, 1 to 2, 2 to 3, maybe 0 to 1, 1 to 2, 2 to 3, 3 to 4 like this. So, you create 0 to 1, 1 to 2 and then find out this axis the frequency 0 to 1 suppose this much, then 1 to 2 let it be this much, then 2 to 3 let it be this much like this. So, this kind of chart you get here, this side is frequency and this side is the particular variable, numeric variable health rating which is plotted here. What it will give from the shape of the histogram, you will know many of the important characteristics. For example, where the mean lies, whether it is rightly skewed or left skewed, that means which kind of occurrences are more frequent, which kind of occurrences are less frequent, and more importantly from histogram you can go to some probability distribution and then you can generalize the population with reference to that particular variable. Another very important chart which you can use in say the descriptive analytics of the incident data is the Pareto chart. Pareto chart is a chart basically which was developed in the probably in the 18th century, I think 18th or 19th, I am not clear, but very long back it was developed, and the Alfredo Pareto, who is the Italian economist, he observed that time that 80% of the world wealth was consumed by 20% of the world population. So, that is why it was also known as 80-20 rule, 80-20 rule, because 80% of world wealth was consumed by 20% of the world population. However, now the scenario is different. I think now it is 98% of the world wealth are consumed by 2% of the world population. Similar such kind of statistics are available. I am not 100% sure, but that is the case. But Alfredo Pareto, he observed this. So, that means, and this one, that is why this is also known as vital few and trivial many. What is vital few? If you see this, suppose you want that 80%, where is 80%? Here is 80%. Okay. So, 80% of the values or problems consumed by here there are many accident causes, but 10 causes are contributing to 80% of the occurrences. Okay, so this axis is basically related to percent, and this curve, this is basically cumulative percent. So, in the cumulative value is 80 here. So, when we come down here, so that means 10 different causes that PC, these are the causes, primary causes that contribute to 80% of the occurrences. Even though there are there are 23 or more causes. So, that means there are vital few causes which are primarily responsible for most of the incidents that is occurring in the plant. So, your objective will be to work on those causes and reduce the accident or incident occurring. Okay. Then I'll discuss something about pattern in time series data. Many times what we do, we basically want to see the performance over time. For example, let it be month 1, month 2, like month n. Okay. So, you want to see what is happening, number of accident per month over time, then this side let it be frequency, which is amount. You may find out the situation is like this. So, when you join, it is like this. So, this is basically a pattern in the data. You may find out the situation is like this. Okay. So, or you may find out the situation is like this. So, many things. Okay. Now, if you want to this from the plant level, suppose you want to see your organization level over past 30 years. So, that time you may find year 1, year 2, year 3 like this, you may find something like this also. Okay. So, what happened, this data when it is measured over time is known as time series data. It may be frequency of incidents occurring, or in the operations management, production management, it is mostly the demand per month or per year. So, here frequency incident per month or per unit time. So, then if you may find out that this data will be, one is average, for example, the second one. Here almost there is no change, because more or less number of incident every month is same. This is average data. Then trend, there is increase or decrease. If you see this data, it is increase in trend. So, that means the safety of the system is deteriorating. There is seasonal influences. For example, there can be suppose this is a 6-month seasonality, maybe like this, then again after 6 months it will happen, or weekly seasonality or quarterly seasonality will be there, it may be there. Then cyclic movement means when you go for long period, long time you consider, and then you may find out that some kind of cycle is created, means mostly these are all long term cycling behavior which we observe in the business cycle. But for safety data, incident data, you may observe if you go over the time, but usually it is not in over time. As everything is improving, it actually usually decreases. But okay, cyclic movement is like this cycle, this second cycle it is there. Then otherwise random remaining, what happened, either all those 4 things will be there: average, trend, seasonal influence and cyclical movement. These are pattern, otherwise data is random. Random over average, random over trend, random over cycle, some kind of. It is not that always you will be, when you plot the data, you will plot like this. So, this is not falling on this smooth curve. So, this is there will be some kind of. Now, if you say this is the cycle, then you subtract the cyclic value from every actual observation, whatever value left, that will be a zigzag random type, that will be the random error. Okay. So, time series data is also very important for safety studies. Okay. So, when you do a record accident, and those accidents or incidents are recorded over time, then either daily, monthly, weekly, quarterly, yearly, some plot can be made, and this will talk about the progress of the performance of the department or the plant or the organization with reference to accidents or incident occurring. So, we have given you some idea of descriptive part, descriptive analytics part, and I hope that you have understood this. Thank you very much.